Welcome children to our next maths class. Today we'll be doing coefficients. So all of you have learned about factors, about terms, about expressions. So today we will learn about coefficients. When we say coefficients, usually the numerical factor of a term is called the coefficient. Or we can say it's a numerical coefficient or a coefficient, simply a coefficient of the rest of the term. Now what does that mean? Now let's see, 3ab. So 3ab is a term, and what is the coefficient of ab? Then we say 3 is a coefficient of ab. And 3 being a number, we say 3 is the numerical coefficient of ab. Similarly, for minus 4x square, the term minus 4x square, the coefficient of x square is minus 4. But it is not that coefficient only means numerical factors. It can also be algebraic factors. So generally speaking, any factor of the term is called the coefficient of the product of the remaining factors. That means suppose we have 3ab, we have the term. So b will be the coefficient of the remaining factors. 3 into a. The product of the remaining factors. 3 into a, that's 3a. Similarly, a will be the coefficient of 3b. And 3 will be the coefficient of ab. 3 being a number is also known as numerical coefficient of ab. Then we have another example, minus 2xy squared. So here we learn what minus 2 will be the coefficient of xy squared. Xy square is the product of the remaining term besides minus 2. So minus 2 will be the coefficient of xy square. X will be the coefficient of minus 2y square. So here x is a variable, but yet it is the coefficient of the product of the remaining terms, that is minus 2y square. Similarly, y square will be what? The coefficient of minus 2x. These are the remaining terms, isn't it? The product of the remaining terms. So I hope that's clear with you, the coefficient. Now when the coefficient of a term is plus 1 or maybe minus 1 also, it is usually omitted. So when we say 1x, we generally write x. Similarly, when it is said minus 1x also, we write minus x. We do not write the minus 1 sign. For minus 1 b square, we write minus b square. For minus 1 x squared z, we write minus x squared z and so on. Now here are some questions I have given you. Identify the numerical coefficient of terms other than constants in the following expressions. So you have to go through the questions very carefully, what exactly they want. Now here we have, these are the questions I have written, and I have given you some solutions also of few sums. Now I have written in the column wise. The first expression is 5 minus t squared. Now here there are two terms, 5 and minus t squared. But 5 being a constant, we don't want a constant here. We want terms which are not constant. So minus t squared is a term which is not a constant. So I write it in the column term. And then from here it becomes easy for us to find the numerical coefficient. So what is the numerical coefficient of this? Minus 1. Now for the next one, 100m plus 1000n. Here there are two terms with variables, isn't it? There is no constant in this term. So I write 100m and 1000n. One below the other because the numerical coefficients are entirely different. Even if it is same, since the terms are different, we write separately. So here 100m, what is the numerical coefficient? 100. And for 1000m, what is the numerical coefficient? 1000. Now for this expression, 4p square q minus 3pq square plus 5. Always read the expression properly because the powers may look similar but they're entirely different. Here it's p square q, pq square. So the powers of the variables are different here. They are unlike terms. And here we have three terms. So we write 4p square q and minus 3pq square. We don't write 5 because it is a constant. And the question is, we do not want a constant here. We want only the numerical coefficient of the algebraic factors. So 4p square q, what is the numerical coefficient of p square q? 4. And in this, what is the numerical coefficient of pq square? Minus 3. So for this term, the numerical coefficient is 4. For this term, the numerical coefficient is minus 3. So that is what they want here, only the numerical coefficient. Okay. So we write here 4 and minus 3. Be careful with the plus and minus sign and complete this table in your classwork copy. Next we have identify the terms which contain x and give the coefficient of x. So the first question, ax square plus 2abx plus c. So here it is x square, not x. Here we have an x, so we write immediately 2abx. Here there is no x, so we do not write c. And then we find the coefficient of x. So what is the coefficient of x? The remaining part, 2ab. So we write coefficient of x is 2ab. Now here we see 1 plus xy. This is a constant. This has an x. This also has an x. So we write the two terms. And since it is plus x and plus xy, so we don't write the plus and we simply write x and xy. So what is the numerical coefficient of this x? 1. There is no other coefficient of x, isn't it here? So we take 1 as the coefficient and we write 1. Now here also we get a coefficient. We have an algebraic coefficient, isn't it? Y. So we write y. So in this case, there is no other coefficient except x. So what does that mean? It is 1x. So we write 1. Here we have y. So what is the coefficient of y? Xy is a, xy is a term. And what is the coefficient of x? Y. So we write here y. So do the rest other two sums. Now the last part. Identify terms containing y square and give the coefficient of y square. So you write down expression 8 minus xy square. So which is the term containing y square? This is the term containing y square. So here you write minus xy square. And what is the coefficient of y square? Minus x. So here you're going to write minus x. So if you follow the stepwise, if you write down the term stepwise and then you write, it's easy to find out the coefficient of y square. So I hope that's clear to you, the coefficients. So do all this in your classwork copy neatly